Okay, so we have this question. The value of the square root of 0.04 divided by 64 is. So the first thing that we're going to do is to separate the square roots. So we're going to break it apart. So we have square root of 0.04 divided by the square root of 64. Now the square root of 0.04 is 0.2. And I'll do a video on showing you how we'd get this answer like quick, like in a blink of an eye, when it comes on to you finding the square root of a decimal. All right, so the square root of 64 is 8. So now we have 0.2 divided by 8. What we're going to do is to change 0.2 into a whole number. So we're going to multiply 0.2 by 10 and also multiply 8 by 10. Now we have 2 divided by 80. Now that we have 2 divided by 80, we are going to simplify 2 divided by 80, and that gives us 1 divided by 40. Now that we have 1 divided by 40, we look at our option and we realize that there's no 1 divided by 40. How do I write 1 divided by 40 as a decimal? And first thing I would like you to think of is 1 divided by 4. What is that as a decimal? Alright, that's 0.25. So if 1 divided by 4 is 0.25, what's 1 divided by 40? Is 0.025. And if it was 1 divided by 400, it would be 0.0025. So you can visualize it as you multiplying 1 divided by 40 and rewriting it as 1 divided by 4 times 1 divided by the power of 10, whether it's 10, 20, whether it's 10, sorry, 10, 100, 1,000. Alright, good. So 1 divided by 40 is 0.025, which means our answer is B. Alright, good. Which of the following is a prime number? First thing that I want you to do is to eliminate. Try and eliminate. Look at the numbers and see which one you know can be divided by a number other than 1 in itself. So we look at 121. Oh yeah, that can be divided by 11. So that's not a prime number. 122 can be divided by 2. That's not a prime number. 125, it ends with a 5. It can be divided by 5. That's not a prime number. So our only option is 127. Alright, so that would be your prime number. Next question. In the figure not drawn to scale, AB is parallel to CD. EG bisect angle BEF and FG bisect angle EFD. Angle EGF is, so they're asking us for the angle of the point G here, EGF, at the point G. So let's look at the properties of angles formed in parallel lines, which are transversal. The angle formed here and the angle formed here would be equal. So if here is y and y, so this would make it 2y. So the angle here would be 2iy as well. So this property would call it alternate angle, or would refer to it as z angle. Alright, good. So we know that the angle AEF is 2y. We also know by looking at this that the angle the angle BEF is 2x, because here is x and here is also x. So on this line, one angle on this side is 2y and the other over this side is 2x. So that means 2y plus 2x equals 180 degrees, using the property that angle on a straight line at a point adds up to 180. Okay, now that we have this, we can simplify to find that x plus y is equal to 90 degrees. So 2x plus 2y equal 180. 2, we factor the 2 out, so we're left with x plus y equals 180. and then x plus y equals 90. So in this triangle, two of the angles adds up to 90. That means the other angle remaining, even though it doesn't look like it, as the diagram is not drawn to scale, is actually 90 degrees. Alright? So EGF is 90 degrees. Okay, that's it. Alright, see you in the next video. Bye bye.